Welcome to 5.7, using congruent triangles. Okay, so how do we explain the statement angle A is congruent to angle D? All right, so BC is congruent to BC by a reflexive property. Therefore, the two triangles are congruent. And if the two triangles are congruent, then all the corresponding pieces are congruent. So we call that corresponding parts of congruent triangles are congruent, CPCTC. So once you've shown that the two triangles or whatever are congruent, then it's CPCTC. Corresponding parts of congruent triangles are congruent. So how do we prove that JM is congruent to LM? Well, again, KM is congruent to itself by a reflexive property. Therefore, the two triangles are congruent by hypotenuse leg. And if the two triangles are congruent, then JM is congruent to LM by CPCTC. Now, everything I just said you should write down. Now, let's take a look at this triangle. This is JNH. Okay, gonna mark everything out here. And then we have G, and K is supposed to be right here at this corner. K and L. Now let's mark those. So the two triangles are congruent because of angle, angle, side. And therefore, GK is congruent to JH because of CPCTC. All right, write a plan to prove that angle 1 is congruent to angle 2. All right, so we can do a two-column proof. You can write it if you want as a paragraph proof. It doesn't matter. So number 7, what do we have that's given? Let's write everything out here. So triangle KFG is is a right angle. So let's do triangle KFG and triangle HGF are right angles, or right triangles. Okay, that's a given. We also have angle K is congruent to angle H. That's also given. All right, those are all given. So I'm going to take these out just a little bit here. So this is F, G, and K, and mark everything. And then we have F, G, and H. So those are the two long triangles pulled out. And we have everything marked. And then the next question is, what do we know? Well, FG is congruent to itself. So FG is congruent to GF. And that's reflexive. Okay. And now you have triangle KFG is congruent to triangle HGF because of angle, angle, side. All right, now we're supposed to prove angle 1 and angle 2, which aren't in these two triangles here. Angle 1 and angle 2 is these little triangles here. Okay, so I can say, now that the two triangles are congruent, that FK and GH are the same. So FK is congruent to GH because of CPCTC. Corresponding parts of congruent triangles are congruent. All right, so I'm going to mark it over here as well. And now let's take a look at those two triangles. So we want angle 1 and angle 2 to be congruent. We have the back two sides being congruent. We have these two angles. But we also have these two angles right here, vertical angles. Okay, so you can say that angle FJK is congruent to angle GJH vertical angles. All right, so we can mark that. And now you have triangle FJK is congruent to triangle GJH, angle, angle, side. And if that's the case, angle 1 is congruent to angle 2, CPCTC. So let's erase all this and then do number 9. All right, number 9. What do we have? We want angle 1 and angle 2. So let's see here. Okay, so I see alternate interior angles, converse theorem, to make PQ parallel to SR. And if those two are parallel, cut by this transversal, then this angle and that angle are the same. So we're going to try to prove, let me mark it in yellow, those two triangles are congruent. So those two triangles, we can say that PQ is parallel to SR because of alternate interior angles converse. We can make them parallel. So if they're parallel, then you also have this transversal and these two triangles, or these two angles being congruent. So angle TPQ is congruent to angle TRS, because of alternate interior angles. All right, and we also know that ST is congruent to QT. They're marked, that was a given, okay? So therefore you have, let's see here, angle, angle, side for the triangle. So the yellow triangles, and triangle TPQ is congruent to triangle TRS, and that's angle, angle, side. So when you say that, then that tells you a whole bunch of different things. So I'm going to erase this and mark a few things on the triangles that contain 1 and 2. All right, so let's erase that. And I'm not sure why it won't erase. There we go. So now we have the top and the bottom triangles are congruent, which makes PT congruent to TR. PT and TR are congruent. All right. So that, let's see, TP and is congruent to TR, and that's CPCTC. Corresponding parts of congruent triangles are congruent. And then you have vertical angles. Angle PTS is congruent to angle RTS, vertical angles. And then you have triangle PTS, congruent to triangle RTS. That would be side, angle, side. And once you have that, then angle 1 is congruent to angle 2, CPCTC. So you just have to keep whittling it down until you have all the parts you need. Okay, so FL is congruent to HN. That's what we're trying to prove. FL is congruent to HN. Well, I see these two triangles are congruent, vertical angles, side, angle, side. And then you have these two blue triangles, vertical angles, and you have side, angle, side for those. So in the top one, FJ is congruent to HK, CPCTC, and JL is congruent to KN, CPCTC. And then you can do segment addition for FL and HN. So that's how we should start this. So you have your givens of all the things that are marked. All right, so just for the sake of time, everything that's marked, all those hash marks that I did not mark. And then we can say angle FGJ is congruent to angle HGK, and angle JML is congruent to angle KMN. and those are all vertical angles. Okay, and then we can say triangle FGJ is congruent to triangle HGK, and triangle JML is congruent to triangle KMN, and those are side angle side, and therefore we can say what I marked, FJ is congruent to HK, and JL is congruent to KN, and that would be CPCTC. And then if we take FJ plus JL, that is equal to FL. You gotta get rid of those segment marks. So FJ plus JL equals FL, and segment addition. And the other one as well, HK plus KN is equal to HN. That's all segment addition. So if they're equal, then they're congruent. So if J plus JL is congruent to FL, and HK plus KN is congruent to HN, and that's a definition of congruence. If they're equal, they're congruent. Okay, so now that they're congruent, and we can do substitution, you can say HK, substitute HK for FJ, and KN for JL. If you do that, then HK for FJ and KN for JL. So HK plus KN is congruent to FL, and HK plus KN is HN. So HN is congruent to FL. Okay? Okay, so prove that the green triangles are congruent. So AD is parallel to BC. Okay, so I'm going to draw parallel lines here and cut by transversals. We have these lines here. So that means alternate interior angles are congruent, and the same thing here. Nope, not there, sorry. These right here are congruent. Okay, it also says that E is the midpoint of AC. So AC and E is the midpoint, which makes those two congruent. So now, this triangle right here, the left triangle and the right triangle, are congruent because of angle, angle, side. All right, so let's go ahead and say everything we just said here. D, B, and C. All right, the given is what they have listed there. And the next thing we're going to say is alternate interior angles, and that would be angle DAE, and is congruent to angle BCE, and then angle ADE is congruent to angle CBE. And so those are both by alternate interior angles. And then we have AE is congruent to CE, definition of midpoint. Okay, and then you have the triangle ADE congruent to triangle CBE, angle, angle, side. Okay, and if those are congruent, then you can say all the other parts are congruent. And so I'm going to focus more on B to E. So BE has to be congruent to DE. So BE has to be congruent to DE. That's CPCTC. Corresponding parts of congruent triangles have to be congruent. Also, you have that angle, but we don't need to say that. We're trying to get the top triangle and the bottom triangle to be congruent, and we have it. So we have these two angles by vertical angles. So angle AEB is congruent to angle DEC by vertical angles. And therefore, the green triangle, triangle AEB, is congruent to triangle CED by side angle side. Okay, side angle side. All right, good. Which triangles are congruent to that triangle right there? Okay, so we have a side and an angle and a side. We also, so you could do side angle side with this one, which has got to be the correct size. You have angle, angle, side. So that's one thing we can look for. We do not have hypotenuse leg, even though it's a right triangle. Okay, so in FDE, you have hypotenuse leg, but that doesn't match what we have for ABC. Okay, and then we have on MKL, you have angle side side, which you can't use that. That's not going to work. And then you have on JGH, you have side, angle, and side. So that one would work. So triangle JGH matches. And Q, we have angle, side, angle, but that's not part of what we have on ABC. We have hypotenuse leg, but we can't use that. So, I'm sorry, we do have angle, side, angle here. Angle, side, angle. So angle, side, angle. That does work, okay? I didn't put that down there, angle, side, angle. So Q and P. So those would be your two answers. Find the value of x. Well, we have an equilateral triangle here. So that means it's equiangular. So that means all angles are 60 degrees. So 2x must be 60 degrees, and therefore x is 30. And the last problem, review, simplify. We have 3y and a plus negative y would be 2y. We have a negative 2 plus a positive 4, which would be positive 2. And that would be that expression simplified. All right, great job. Let's go back to the beginning.